Helga invests £4,000 in a savings account, and after T days, her investment is worth Y pound. The rate of increase of Y is KY, where K is a constant. So this is going to be when time is 0, that Y is equal to 4,000. Write down a differential equation in terms of T, Y, and K. So we're told the rate of increase, that is dy by dt. It means the rate of increase with respect to time is ky. So that ends up being our equation, in fact. And we'll have to solve it to find the value of Helga's investment after t days, giving our answer in terms of k and t. So we cannot integrate this directly. K is a constant, but y is a function of t. So we need to use separation of variables here. Divide through by y, we're going to get 1 over y dy by dt equal to k. And then we can integrate both sides with respect to t. Alternatively, you might be somebody who times this through by dt and then integrates. You'll get the same thing because using the chain rule, this cancels down to dy. Yeah, we can integrate now. So I'm going to get ln modulus of y equals kt plus my arbitrary constant. And I think I'm gonna make it so y is equal to e to the kt plus c. I'm going to be subbing in my constant in a second, but it's actually, in this case, it's best to just do a few little steps. My next step is going to be to go e to the kt times e to the c and write it e to the c as a new constant. So it's going to become capital A e to the kt. A equals e to the c. So there's my y. Now I can just sub in t equals 0 and y equals 4,000. So 4,000 is simply going to equal a. That's always the case with these exponentials, because this is always our initial value, because when t is 0, e to the 0 is just 1. And then finally, so our final answer is that y equals 4,000 e to the kt. We don't have any other information. We can't work out what k is at the moment. It's given that k is 1 over 365 times ln of 1 plus r over 100, where r% is the rate of interest per annum. During the first year, the rate of interest is 6% per annum. So r is going to be 6 in the first year. Find the value of Helga's investment after 90 days. Again, that's in the first year. So k is going to equal 1 over 365 times ln of 1.06. And therefore, when t equals 90, y is going to equal 4,000 multiplied by e. I'm going to leave it in as k, or e to the k times 90, or e to the 90k. Just put this into your calculator now, and it ends up giving 4,057.8855. It doesn't say, write it to the nearest penny, £4,057.89. Now for the final part, and I think this is pretty tricky, the trickiest bit of the pure part of this paper, to be honest. I'm going to go for it in two different ways, slightly different approaches. One from the mark scheme, but first of all, this is how I did it. We're told after 1 year, 365 days, the rate of interest drops from 6% to 5% per annum. Find the total time it will take for Helga's investment to double in value. That is, become £8,000. So I first of all looked at how much Helga would have after 365 days. Now, t equals 365. So if we sub that in, you'll do k times 365, which is just ln 1.06. And if you do e to the power of that, you actually just get 1.06. It becomes the multiplier by itself, 4,000 times 1.06. And this is 4240. That's how much Helga will have after 1 year. And then k is going to equal 1 over 365 learn 1.05. So for time greater than 365, y is now going to equal, I'm going to create a new function, 4240, because that's the amount after 1 year, e to the k with this new value of k, and then it's going to be the time, but it's not going to be the time at the beginning now. There's going to be like a slight shift. It's going to be t minus 365. So it's like a new function that I've created. That's quite tricky, I think, but I'm hoping it makes sense. I just kind of want to talk about it a little bit more. So I worked out how much Helga had after 1 year, this 4240. That's like my new kind of starting value. So that's why I put it here. And then I've got e to the k t kind of. K is now a new value. And remember, t is actually the time relative to the start. So I just need to kind of say, because we're after 1 year, I need to minus 365. Because you can see when t is now 365, we're going to get that y is 4240. And when t is, say, 375, we're going to be looking 10 days in terms of the new model. And then what I want to do is set this equal to 8,000. So solve when y equals 8,000. So that means 8,000 divided by 4240 is going to equal e to the k. I think I'm going to sub it in. So it's going to be t minus 365 over 365 ln 1.05. And this ends up being 100 over 53 here. And let's do ln of both sides. So ln of 100 over 53 is equal to t minus 365 over 365 times ln 1.05. I can times through by 365. I can divide through by ln 1.05. We get t minus 365 equaling 4749.53, which means t, adding on 365, is 5114.534. So total number of days, right, it's not going to be 5114. We didn't quite have 8,000 there. It's going to be 5115. Here's a slightly different approach. It's actually very similar when it comes down to it, but this is what the mark scheme does. So it says after 1 year, we've increased by a factor of 1.06. That's what I did in my calculation. I actually worked out what it was. So we wanted to overall increase by a factor of 2. So we need a further increase by 2 over 1.06 from then on. And then basically we just look at the exponential part, ignore the 4,000 or whatever. We need this to be, going up by this amount. And we're almost like, this is now the time from 1 year onwards. That's what t is. So I did t minus 365, whereas they've left it in terms of t, but they have to add on 365 at the end. And then it's essentially the same equation. Okay, it's just instead of this cancelling and everything, it's become the same approach. Timesing through and everything to give the 4750, just like I had. I mean, I think that's a little bit early to round. I didn't round until the very end, and then add on the 365 to give this. So look, there's no way about it. This is quite complicated. The fact that k is changing is what makes this question different. So I'm just going to go through like the methods again, kind of try and talk about both at the same time. So we know, I worked out the investment after 1 year, which they didn't do in the second part. And then I created a new function with t minus 365. You could avoid that. You could not, you could just put t in and just say t is the time after, like call it maybe something new and say it's the time after like the first year, and then just add on 365 at the end. I tried to work in terms of like a entire function and then work it through by setting equal to 8,000, and it all worked out. Or with the second approach, it was like not worrying too much about the 4240, just instead getting this as a factor, very subtle, I think, and creating the equations from there as well. But I'm hoping one of these methods makes sense. This is tough. Well done if you understand it, and for just listening and like look over it again, and hopefully it will come together. Well done.